Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. Yeah, so when we finished polynomials, I had told you that I'll gather a set of important proofs and, explain them to you. So that was, I told you, I think during the month of July, somewhere towards the end of July. Yeah, now I did not have time to prepare the presentation. Now it's ready, children. So we are going back to polynomials. We are going to see some important results or some important questions in this chapter, polynomials. So this is the first one for you. If x square minus 1 is a factor of, this polynomial given here, then show that a plus c plus e is equal to b plus d is equal to 0. That means you must prove that a plus c plus e is equal to 0 and also b plus d is equal to 0. See, what do we mean by a is equal to b is equal to 5? That means a is 5 and b is also 5. So when a is 5 and b is 5 and say c is also 5, we can write a is equal to b is equal to c is equal to 5. Because all the three, A, B, and C, all of them or each of them is equal to 5. So you can also write it like this. Similarly, A plus C plus E should be 0. B plus D should also be 0. Then we can write, A plus C plus E is equal to B plus D is equal to 0. All right. Let's see how to prove this. So to use the, the remainder theorem, sorry. So to use the remainder theorem, we need linear factors. But here the factor is quadratic. I think I should have some water. 1 minute, children. I'll just get back. I'm not able to talk. I'll just show you the answer. Please work the answer. I'll just come back. Please work the answer, children. I'm just coming back. Yes, children. Yeah. So the factor which is given is a quadratic factor. The factor which is given is a quadratic factor. So we have to factorize it and find the linear factors. So see here, first of all, the polynomial which is given, it does not have a name. So let us first assign a name to the polynomial. Don't read ahead of me. Please follow what I'm saying. So the polynomial given does not have a name. So let's name it. So let P of X be the given polynomial. Let P of X be the given polynomial. Now what is given? X square minus 1 is a factor of P of X. X square minus 1 is a factor of P of X. That's what is given to you. But what is about X square minus 1? It is quadratic. So we'll have to find its linear factors by factorizing it. So X square minus 1 is of the form A plus B into, A square minus B square. So its factors are A plus B and A minus B. x square minus 1 is like x the whole square minus 1 the whole square. A square minus b square. So which can be factorized as a plus b into a minus b, or a minus b into a plus b, whatever. So x minus 1 and x plus 1 are the two linear factors of p of x, because x square minus 1 is a factor of p of x. So the linear factors of x square minus 1 are x minus 1 and x plus 1. So they also will be factors of p of x. Like if now the number 20, 10 is a factor of 20. So the factors of 10 are 5 and 2. So 5 and 2 are also factors of 20. Suppose the number is 20. We know that 10 is a factor of 20. Now, what are the factors of 10? 5 and 2. So since 10 is a factor of 20, 5 and 2 are also factors of 20. In the same way, since x square minus 1 is a factor of p of x, its factors x plus 1 and x minus 1 will also be factors of p of x. Okay, now take them up one by one. X minus 1 is a factor of p of x. So equated to 0, x is equal to 1. So find, so we know that p of 1 is 0. Why p of 1? Because p of x. Because p of x. So now we know that p of 1 is 0. Why? Because x minus 1 is a factor. If it's a factor, the remainder will be 0. I've told you that when you say p of 1 is equal to, what you write here is a remainder. What you write here is the remainder. And what if you don't know the remainder, you cannot write it. But here you know the remainder. How do you know the remainder? Because x minus 1 is a factor of p of x, which means the remainder is 0. Which means when you divide p of x by x minus 1, the remainder is 0. So that is what is 0 here. Since x minus 1 is a factor of p of x, when you divide p of x by x minus 1, it's factored. The remainder will be 0. So that's what is 0 here. P of 1 is equal to 0. Now, how do you work this? In P of x, wherever there is x, you'll have to use 1. In P of x, wherever there is x, use 1. So that's how you get this. And then, 1 to the power 4 is 1. 1 cubed is 1. 1 square is 1. So you finally get a plus b plus c plus d plus e is equal to 0. Sorry, children, I don't know. I'm not able to talk. My throat is irritated. Yeah. Yeah, children. So now the next factor, x plus 1. X plus 1 is a factor of p of x. So again, x plus 1 is equal to 0. So x is equal to minus 1. But since x plus 1 is a factor of p of x, we know that p of minus 1 will be equal to 0. Remainder is 0. When you divide p of x by its factor x plus 1, the remainder will be 0. So how do you work p of minus 1? In p of x. In p of x, wherever there is x, use minus 1. Use minus 1. So p of minus 1 is this one. This one is p of minus 1. Is equal to 0. This is equal to 0 here. Now be careful while evaluating this. Be very careful. Minus 1 to the power 4 is 1, positive 1. But minus 1 to the power 3 is minus 1. You know this. So be careful. You can see I've shown that step here. So you can help yourself. So we get another equation like this. A minus b plus c minus d plus e is equal to 0. Now let us add and subtract these two equations. Now equation 1 plus equation 2. Okay, write the equations one below the other and add them. Adding means without changing the signs of the second equation. So what you get, a plus a is 2a plus b minus b gets cancelled. C plus c is plus 2c. Plus d minus d gets cancelled. Plus c is plus 2e. I'll repeat. Plus a, meaning a plus a, 2a. Plus b minus b cancels. C plus 2c. Plus d minus d cancels. E plus e. So 2e plus 2e is equal to 0. So 2 is common. So in bracket, you have a plus c plus e is equal to 0. 2 comes for division to the other side. So a plus c plus e is equal to 0 by 2, which is 0. Now, we proved one part. See, we proved that a plus c plus e is 0. A plus c plus e is 0. Now, subtract the two equations. So write the first equation, write the second equation, and change the signs. So that is subtracting. When you change the signs in the second equation, you're subtracting the two equations. So change the signs. So on changing the signs and simplifying, we get a minus a cancels. Plus b. See the new sign. Plus b, new sign. Plus 2b. Plus c minus c cancels. Take the new sign. Plus c minus c cancels. Plus d, plus 2d. Take the new sign. Plus d, plus 2d. Plus c minus c cancels. Is equal to 0. So 2 is common. Bracket b plus d is equal to 0. Then 2 comes for division. So 0 by 2 is 0. So b plus d is 0. So we also proved that b plus d is 0. See here, b plus d is 0. That means a plus c plus e is equal to b plus d is equal to 0. Take down, children. Write down quickly. Done, children?
Yes, ma'am.
Completed,
Okay.
ma'am.
All right. Is it easy? Any questions?
No, ma'am.
Okay. So we first name the polynomial p of x, and then the factor is quadratic. So we factorize it and find the two linear factors. Then we take up the factors one at a time. X plus 1 is a factor of p of x. X minus 1 is a factor of p of x. And we work that. So we get two equations. 1 and 2. Add the two equations, subtract the two equations. That is Adding meaning in the second equation, don't change the signs. And then subtract the two equations. So change the signs in the second equation. So that will give you the results. I'll let you. This is the next one. So if both x minus 2 and x minus half are factors of this polynomial, show that p is equal to r. All right. I'll let you know. So again, this polynomial is not named. This polynomial is not named. See here, this one. So let's name it. I've called it f of x. Let f of x be equal to px squared plus 5x plus r. Now it's given, see here, both the factors are linear. So you can take them directly. Both of them are linear, x minus 2, x minus half. So first, x minus 2 is a factor of f of x. X minus 2 is equal to 0, x is equal to 2. Since it's a factor, f of 2 will be 0. So how do you work on f of 2? F of 2 means wherever there is in f of x, wherever there is x, you must use 2. So see here, p into 2 square plus 5 into 2 plus r is equal to 0. This is equal to f of 2 is this one is equal to 0. F of 2, this one is what is here, f of 2 is equal to 0. So now 2 square is 4. So 4p plus 10 plus r is equal to 0. So have p and r on one side, take the constant to the other side. 4p plus r is equal to minus 10. We have two variables, p and r. So have the variables on one side, take the constant to the other side. So 4p plus r is equal to minus 10 is the first equation. Now take up the next factor given, x minus half. X minus half is a factor of f of x. So x minus half is equal to 0, x is equal to half. That means f of half, like f of 2 is 0, f of half is 0. Because x minus half is the factor. Factor means the remainder will be 0. So now f of half means in f of x, wherever there is x, you must use half. So p into half the whole square plus 5 into half plus r. Only x, wherever there is x, you must use half, not for r. P and r will be as it is. Wherever there is x, use half. So that is the step. Then 1 by 2 the whole square is 1 by 4. 1 by 2 the whole square is 1 by 4 and 5 into half is 5 by 2 plus r is equal to 0. Then common denominator, you can see here common denominator, cross multiply, 0 into 4 is 0. And then take the constant to the other side. P plus 4r is equal to minus 10. Take the constant to the other side. So p and r on one side and the constant to the other side. Now we'll solve the two equations. It's actually not solving the two equations. It is equation 1. You don't write like this. Write equation 1 minus equation 2. Equation 1 minus equation 2 gives. Please write like this. Equation, I'll tell you why minus. I'll tell you. So equation 1 minus equation 2 gives. So write the first equation, write the second equation, change the signs in the second equation because it's subtracting. So now 4p minus p, 3p, plus r minus 4r, minus 3r, minus 10 plus 10, 0. Take the new signs. So now 3p minus 3r is equal to 0. That means 3p is equal to 3r. 3p is equal to 3r. So 3 on either side gets cancelled and we get the result p is equal to r. P is equal to r. Now, all right. Now, how else you can work this? It's not, you can also do this. You can take out after the step, like 3p minus 3r is equal to 0. You can even take out 3 common children. So you get 3 into p minus r is equal to 0. So 0 by 3 is 0. So p minus r is equal to 0. So p is equal to r. Like this also you can work. You can take out 3 common. P minus r is equal to 0. Then 3 goes for division to the other side. 0 by 3 is 0. So P minus R is equal to 0. So P is equal to R. All right. Now let's see what happens when we add the two equations. You will get a different result. If you are asked to prove that result, you will have to add. So now how do we know if we have to add or subtract? You should add. If you add, you don't get the result, then you subtract. It should be one of these two. It will be one of these two. Either you add or you subtract, whichever gives you the required result. So now when you add the two equations, let's see what we get. 4P plus R is equal to minus 10. P plus 4R. In rare cases, you will get it when you add. But mostly when you add, you will get one equation. When you subtract, you will get a different equation. We'll see what happens here. So 4P plus R is equal to minus 10, P is equal to minus 10. Adding meaning we should not change the sign. So what will that give us? 5P plus 5R is equal to minus 20. You can take out 5 common. So P plus R is equal to minus 20 is equal to minus 20. So P plus R is equal to minus 20 by 5. So we get P plus R is equal to minus 20 by 5 is what? Minus 4. So you're getting something different. So if you're asked to prove that, if it is show that P plus R is equal to minus 4, supposing show that P plus R is equal to minus 4, then you have to add the two equations. So what will happen? You will actually add, you will not get the required result. So you will subtract. When you subtract, you get it. Is it okay, children? Understand?
Yes, ma'am.
Okay. Yeah. So depending on whatever is asked, so you will actually not know whether you have to add or subtract. You add, you will not get the result, so you have to subtract. Done, children?
Completed, ma'am.
Okay. Others?
1 minute, ma'am.
Yeah. Okay.
Completed, ma'am.
All right. Done, children? Anybody still writing?
No, ma'am.
Okay. If A plus B plus C is 0, then prove that A cube plus B cube plus C cube is equal to 3ABC. So see here. So we know that this is an identity. You know this identity. A cube plus B cube plus C cube minus 3ABC is equal to A plus B plus C into A square plus B square plus C squared minus AB minus BC minus CA. This is an identity. You know this. So first write the identity. Now in the identity, substitute this. What is given? A plus B plus C is equal to 0 is given to you. This is given to you. You'll have to prove this one. But what is given? A plus B plus C is 0 is given to you. So first you write the identity. You write this identity. And then in this identity, in place of A plus B plus C, substitute 0. So what will you get? A cube plus B cube plus C cube minus 3ABC is equal to 0 into the second expression. So what is 0 into this? 0. So when you transpose, you get A cube plus B cube plus C cube is equal to 3ABC. So first write this identity. Then in the next step, in place of A plus B plus C, use 0. 0 into this expression is 0. Then transpose this. Minus 3ABC will come here as plus 3ABC. So you get the result A cube plus B cube plus C cube is equal to 3ABC. See, this entire thing becomes 0. This full thing becomes 0. This full thing is 0. 0 into this expression is 0. That's all. So now when you bring this here, it will become plus 3ABC. So you don't have to write 0. Plus 3ABC. So we have proved that A cube plus B cube plus C cube is equal to 3ABC. Right on, children? I'll also do this in a different way. We have done this earlier. I'll do it again. This can be proved in another method also. Take down this. I'll also do that for you.
Completed, ma'am.
Yeah.
Completed, ma'am.
1 minute, ma'am.
All right.
Completed, ma'am.
All right.
Completed, ma'am.
All right, children. Yeah. Now this is the alternate proof. Please write down. I'll be explaining as I write it. All right. So what is given? What is given? A plus B plus C is equal to 0 is given to you. Now transpose any one to the other side, like you can write A plus B is equal to minus C, or you can write A plus C is equal to minus B, or you can write A, B plus C. B plus C is equal to minus A, right? Any one of these three. All these three will give you the same result. All right. You can transpose any one variable to the other side. You transpose A or B or C, any one to the RHS. Okay. See, if you transpose C, it will become minus C. If you transpose B to the other side, transpose B, you will get A plus C is equal to minus B. If you transpose A, you will get B plus C is equal to minus A. You can do any one of these three. Okay, so we are given that A plus B plus C is 0. Say we take C to the other side. So A plus B is equal to minus C. Now cubing on both the sides. Cubing on both sides. What do we get? Cubing on both the sides. We get A plus B, the whole cube, is equal to minus C, the whole cube. Now what is a plus b the whole cube? A cubed plus b cubed plus 3ab into a plus b is equal to minus c cubed. Because minus c the whole cubed is minus c into minus c into minus c. So that minus sign will remain minus c cubed. A plus b the whole cubed is a cubed plus b cubed plus 3ab into a plus b is equal to minus c cubed. Now a cubed plus b cubed plus 3ab. Now what is a plus b? Go back here. Go back here. What is a plus b? See here. What is a plus b minus c? What is a plus b? It's equal to minus c. So instead of a plus b, instead of this a plus b, you say minus c. This 3ab we write as it is. In the bracket, we have a plus b, no? So instead of a plus b, you write minus c. So minus c is equal to minus c cubed. Now a cubed plus b cubed, when you multiply plus 3ab into minus c, you'll get minus 3abc because plus into minus minus 3ab into c is 3abc is equal to minus c cubed. So on transposing accordingly, a cubed plus b cubed minus c cubed to the LHS. So plus c cubed is equal to minus 3abc to the RHS. So is equal to 3abc. Hence proved. Hence proved. Yes, children, write down.
Completed.
All right.
Completed.
All right.
Completed, ma'am.
Yeah. All right. Next one. This is the next one. Okay. So verify that. Yeah. So verify that x cubed plus y cubed is equal to, we know this is an identity. You'll have to verify this. Verify that x cubed plus y cubed is equal to x plus y into x square minus xy plus y square. We know this one as an identity. We need to verify. That is check and show that it's true. So for that, you just have to find the product. You just have to find the product. Take up the RHS. See the RHS. You have two expressions. This is a binomial. This is a trinomial. You'll have to multiply. This is a binomial. This has two terms, binomial. This has three terms. It's a trinomial. You'll have to multiply this binomial and this trinomial. So take up the RHS. X plus y, x square minus xy plus y square. Now, how do you multiply? First term, x into the second bracket. The first term x into the second bracket. Then the second term plus y into the second bracket. This is how we multiply. This is how we multiply. Yes or no, children? Understand how to multiply?
Yes, ma'am.
Yes, ma'am.
Yeah. All right, children. So that's what it is. And then you know x into x square is x cubed, x into minus xy is minus x square y and stuff like that. So then after you multiply, you can see here minus x square y plus x square y plus xy square minus xy square cancels. So you're left with only x cubed plus y cubed. So we have proved that this one is equal to this one. So therefore, x cubed plus y cubed is equal to x plus y into x square minus xy plus y square. Same thing here, children. Work both. Please work both, children. Done, children? Please let me know.
Completed, ma'am.
Completed. Very good.
1 minute.
Yeah.
Completed, ma'am.
Yeah. Anybody still writing? I'll wait.
1 minute, ma'am.
Okay. I hope, we are not taking screenshots, children. You're all writing in your notebook, right?
Yes, ma'am. Yes, ma'am.
Yeah. And again, it should not be blind copy, children. As you're writing, you must understand what you're writing. You must understand what you're writing. This is too simple, so I just left it to you. So here also, there are like terms which get cancelled. Plus x square y minus x square y. Plus xy square minus xy square.
Completed, ma'am.
Yeah, very good. Next one. Use factor theorem to verify that x plus a is a factor of x to the power n plus a to the power n for any odd positive integer. All right, so for that, we need to first understand what is given. Now, x to the power n plus a to the power n. Let's take some examples where, n is any positive integer. For any positive integer n. Oh. Use factor theorem to verify that x plus a is a factor of x power n plus a power n for any odd positive integer n. Okay, where n is any odd positive integer. I think missed it while writing. Yeah, where n is any odd positive integer, children. Okay. Where n is any odd for any odd positive integer n. For any odd positive integer n. All right. So that means positive, first positive, okay. Then odd. So that means what? X to the power 1 plus a to the power 1, which is nothing but x plus a. X power 3 plus a power 3. Or x power 5 plus a power 5. X power 7 plus a power 7. X power 99 plus a power 99. Because n, both are n, no. So that's why you should take the same power. See here. Both n only. So if you say x power 101, a power 101 only. What is the definition for n? Who is n? N is any positive integer, odd positive integer. Positive integer we understand. It's not negative, positive integer. Odd positive integer. So that means 1, 3, 5, 7, 9, 11, and so on. So you should prove that, you must prove that x plus a is a factor of x power n plus a power n, where n can be any odd number. Where n can be any odd number, whatever be the odd number, whatever be the power of odd power of x and a. So like x to the power 333 plus a to the power 333. 333 is odd. That means x plus a will be a factor of this one. X power 99 plus a power 99. N, see here, n, both are n. N is 99. X power 99 plus a power 99. So the power is odd. The power is odd. It is positive, it is odd. So x plus a is a factor of this one. That's what you'll have to prove. It's not given. You'll have to prove that. You must prove that x plus a is a factor of this expression, x to the power n plus a to the power n, when n is any odd number. When n is any odd number. So children, to prove that x plus a is a factor of some other polynomial, you must prove that the remainder is 0. That means x plus a is equal to 0. X is equal to minus a. X is equal to minus a. So now if you call this f of x is equal to x to the power n plus a to the power n, you must prove that, or you should show that f of minus a is equal to 0. That's all. Let me write it 1 minute. Let me do it slowly. 1 minute. Now just watch what I'm writing. Let f of x be equal to x to the power n plus a to the power n. This is the polynomial. Okay. Now you cannot, okay, x plus a, equate this to 0. X plus a is equal to 0. So what do you get? X is equal to a. Now you must, x is equal to minus a. Now you'll have to find, you cannot say that f of minus a is equal to 0. No. It's not given it is a factor. You'll have to prove it's a factor. That means you must find f of minus a and show that it is equal to 0. If it is given to be a factor, then you will write f of minus a is equal to 0. But if you have to prove it's a factor, you will have to find f of minus a and you must get the answer as 0. If you get the answer as 0, that means the remainder is 0. Therefore, it is a factor. If you understand what is to be done.
Yes, ma'am.
Yes, ma'am.
So we need to read the question many times to understand the question. So we have a polynomial x to the power n plus a to the power n. So we'll name it, we'll call it say f of x. Now we have a linear expression, a linear polynomial x plus a. Okay, we have a linear polynomial x plus a. We need to show that this linear polynomial x plus a is always a factor of this one where n is odd. You must prove that x plus a is a factor of this where n is odd. So to prove it's a factor, equate this one to 0, this linear expression to 0 or the linear polynomial to 0. Find the value of x, you get minus a. Now you must find f of minus a and you must get the answer as 0. If you get 0, then you can say that x plus a is a factor of this one where n is any odd positive integer. So see here, understand very carefully, children. Don't go ahead of me. Now see here, let f of x be equal to x power n plus a power n. Okay, then x plus a is equal to 0, x is equal to minus a. Now see this, to find f of minus a, to find f of, we have to find f of minus a. So what is f of x? F of x is x to the power n plus a. I've just written it again. Okay, this one. Now we have to find f of minus a. How do you find f of minus a? F of minus a. In f of x, wherever there is x, you should use minus a. There's only x here. There's x only here. So minus a to the power n plus a to the power n. Is this step understood, children? All of you?
Yes, ma'am. Yes, ma'am.
In f of x, wherever there is x, we are replacing that with minus a. That's all. Next, what is minus a? What is minus a? Minus 1 into a. You'll understand towards the end why we are writing like that. Okay. So what is minus a? Minus a is minus 1 into a. See, minus a can be written as minus 1 into a because a into 1 is a and minus a. Minus a can be written as minus 1. Don't write 1 into minus a. Don't write like that. Write minus 1 into a. Don't write 1 into minus a. Don't write like that. Write minus 1 into a. So minus a is minus 1 into a. This power n as it is plus a power n. Is this step understood? Is this one understood?
Yes, ma'am.
What we're doing is minus a. We are just writing minus a in a different way. Minus 1 into a. Okay. Now you've studied this when you learned exponents last year. If you have say 3 into 5, the whole square, this is nothing but 3 square into 5 square. The power is applicable for everything inside the bracket. Or okay, if you have AB, the whole square, it is nothing but A square, B square. The power is applicable to every term inside the bracket. So AB, the whole square means A square into B square. Yes or no?
Yes, ma'am.
Yeah. So now, yeah. So now here we have -1 into A, the whole power n. So that means this n, the power n will be applied to -1 and for A. So see the next step, it's -1 in the next step, -1 to the power n into, I've not put the into multiplication sign. It's understood, it's multiplication into A to the power n plus A power n. See this? We're just distributing the power. We are just distributing the power. -1 to the power n into A to the power n into A to the power n. Then this plus A to the power n plus A to the power n. Is that understood, children?
Yes, ma'am.
Yes.
Yeah. Now, this is like one term. This is the second term separated by a plus sign. This is here. There's a plus minus signs. They are the separators. So you can see a plus sign here. So this is one term. This is another term. What is common between these two terms? A to the power n is common. Bring it out. Then what will you get inside the bracket? This -1 to the power n plus 1. Because that's, see, when you multiply this and this, you should get the first term. When you multiply this and this, you should get the second term. Please check if you're getting it. So if you have like AC plus C, what will you do? C is common, then A plus 1. If you have AC plus C, C is common. C into A is AC. C into 1 is C. Similarly, this is one term, this is another term separated by a plus sign. Now the two terms have A power n common. So take out the common factor. Now, what to write in the bracket? Since there are two terms here, you'll get two terms in the bracket also. Now, A power n into this one will give you the first term, -1 to the power n into A to the power n. And when you multiply these two, A to the power n into 1 is A to the power n. So that's the next step. Now you can see that in the bracket, you can find the value of this. You can find the value of this one. How you can find the value? Because we know that when -1 is raised to an even power, it's a positive one. But when -1 is raised to an odd power, it's a negative one. We know this. See, when +1 is raised to a positive power, or sorry, let me write everything. Now, 1 raised to an odd power, 1 raised to an even power, -1 raised to an odd power, -1 raised to an even power. All right, let's evaluate. Let's evaluate them. 1 raised to an odd power. See, it is positive 1. Then how can you get -1 as the answer? When 1 is positive, when the base is positive, you cannot get a negative answer. The base is positive. What is exponents? You multiply the base some number of times. 1 to the power 3 means multiply 1 with itself 3 times. 1 into 1 into 1 is 1. 1 to the power 10 means multiply 1 with itself 10 times. 1 into 1 into 1 into 1 into 1, 10 times. 1. So when a positive 1 is raised to an odd or an even power, the answer is always a positive one. Because the base is positive, then how will you get a negative answer? When it's a positive 1, when the base is a positive 1, the answer is always 1. It will not be -1. But when the base is -1 to the power 3, odd power, -1 into -1 into -1. So you'll have minus sign 3 times. So the answer is -1. But -1 to the power 10. How many minus signs you'll have? 10 minus signs you'll have. And you know that minus into minus is plus. Minus into minus is plus. So 10 minus signs will become positive finally. 1 into 1 into 1 into 1, 10 times is 1. Here, minus 1 into 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 minus 1. Say 6 times. 6 times I've written. Minus into minus plus. Minus into minus plus. Minus into minus plus. So all now it's all plus. So plus into plus into plus is plus. Now 1 into 1 into 1 into 1 into 1 into 1 is 1. So here minus 1 is the base. It is raised to an odd power. How do we know it is odd? Because it's given that n is odd. N is odd for any odd positive integer n. N is odd. It's given to us. So here the base minus 1 is raised to an odd power. So when minus 1 is raised to an odd power, say 11, the answer is minus 1. When minus 1 is raised to an odd power, like say 91, the answer is minus 1. It's not 91. 1 into 1 into 1 into 1, 91 times. Then minus into minus into minus 91 times. That will be minus 1. So minus, so that's what I've explained here. N is odd positive integer. N is an odd positive integer. Therefore, minus 1 to the power n is equal to minus 1. This is understood, children, what I've written here?
Yes, ma'am.
N is an odd positive integer. Odd, that's, don't get confused. Positive integer, odd positive integer, meaning odd number it is. So if n is odd, if this n is odd, you will get minus 1. So now in the bracket, what you do, write this as it is, write this a to the power n as it is. Now this is minus 1, this answer is minus 1. That we did not remove the power. We know that minus 1 raised to any odd power, the answer is going to be minus 1. So the answer for this one is minus 1. And this plus 1 as it is. This plus 1 as it is. Now minus 1 plus 1 is 0. And a to the power of n into 0 is 0. So we have worked and got f of minus a is equal to 0. We have found the value of f of minus a. We have found the value of f of minus a. And what did we get? We got 0. So that means x plus a is a factor of f of x. That means f of x plus a is a factor of f of x when n is any odd positive integer. Yes or no, children? Understand?
Yes, ma'am.
Yeah, please write down
Yes, ma'am.
carefully. Take your time, children. Don't just blindly copy. You're learning. You can go through the slide once again. Write it slowly, understand clearly. I'll just come back, children. Please write.
Completed, ma'am.
Completed, ma'am.
Completed, ma'am.
Yeah, children. So did you make this change in the question? For any odd positive integer n.
Yes, ma'am.
Yeah, n is an odd positive integer. Okay. Yeah. All right, children. Next one. So here we'll have to given that a square plus b square plus c square minus ab minus bc minus ca is equal to 0, we need to show that a is equal to b is equal to c. That is, you must show that this condition can be true only if a, b, c are equal. This condition is true only when a, b, c are equal. So we are given this. If a square plus b square plus c square minus ab minus bc minus ca is equal to 0, then prove that a, b, c all are equal. All right. So this is what is given to us. Take up that. We are given a square plus b square plus c square minus ab minus bc minus ca is equal to 0. Take up that. Multiply the LHS and see, this is given to you. You don't have to prove this. This is given to you. You'll have to prove this one. So take up what is given. Take up what is given. This is given. Multiply both the sides by 2. Multiply both the sides by 2. That is the LHS by 2 and the RHS by 2. So see here, that's the next step. Multiplying the LHS by 2 and the RHS by 2. That's the next step. Then multiply every term in the bracket by 2. So 2 into a square, 2a square, 2 into b square, 2b square, 2 into c square, 2c square, like that. And here 2 into 0 is 0, not 2. 2 into 0 is 0. That's the third step. That is the third step. Okay. Now break down. What is 2a square? A square plus a square. What is 2b square? B square plus b square. What is 2c square? C square plus c square. Then write that minus 2ab minus 2bc minus 2c as they are. Just break up 2a square, 2b square and 2c square. Only these three. A square plus a square, b square plus b square, c square plus c square. That's the next step. Now for every middle term, now minus 2, see here, minus 2ab. Can you see it here in this bracket, minus 2ab? Minus 2bc here in this bracket, minus 2ca in this bracket. Okay, so we have written these three. 1 minute. Here, minus 2ab here, minus 2bc here, minus 2ca here. Okay, now we have 2a squares, 2b squares and 2c squares. Now this is ab, so you need one a square and b square. This is bc, so you need one b square and one c square. And here we have ac, so you need one c square and one a square. You can write this as ca. It's 2ca, no? Write as ca. Okay, so what I said, minus 2ab, minus 2bc, minus 2ca, minus 2ca. Okay, now since it's ab, take an a square and b square here. bc, so b square and c square. ca, c square and a square. So like that you've used the two a squares here. There's one a square here and one a square here. There's one b square here and one b square here. There's one c square here and c square here. And then 2ab minus 2ab minus 2bc minus 2ca. So children, here there are in total there are 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have grouped them in threes. 3, 3, 3. So like this 9 terms. We have grouped the 9 terms suitably like this. All right. Now what is a square plus a square minus 2ab plus b square? A minus b the whole square. What is b square minus 2bc plus c square? B minus c the whole square. And c square minus 2ca plus a square is c minus a the whole square. Like a square minus 2ab plus b square is a minus b the whole square. Similarly, the other results, b minus c the whole square and c minus a the whole square is equal to 0. The RHS is equal to 0. Now, what is the meaning of this equation? A minus b the whole square plus b minus c the whole square plus c minus a the whole square is equal to 0. It's a sum. See here, it's a sum. And what can we say about a minus b the whole square? It is always positive. Because, now when 5 is positive and you square it, you get a positive 25. And when 5 is negative and you square it, you still get a positive 25. When you square something, it is always positive. When you square, the result is always positive. When you cube, the result may be positive or negative. Because when you cube 3 cubed is 27. But minus 3 cubed is minus 27. Minus 3 cubed is minus 27 because minus 3 into minus 3 into minus 3 is minus 27. When you cube, the result may be positive or negative, but when you square, the result is always positive. The result is always positive. So whatever is here, it is squared. So the answer is positive. Whatever is this, we don't know what the value of b minus c is. We don't know the value of b minus c. B minus c, that answer may be positive or negative. But when you square it, the result is positive. Similarly, c minus a. What is that answer for c minus a? We don't know. The answer may be positive or negative. It can be 0. We don't know anything it can be. But when you square it, it is positive. It can be 0 or it is positive. All right. Now, some positive value plus some positive value plus some positive value. How can it give you 0? See here, there's a positive value. This is also positive. This is also positive. You're adding them. You're adding them. How can you get 0? You can get 0 only when all these are zeros. Because see, supposing you square this and you say get 9. And this one when you square, say you get 4. And this one when you square, say you get something like 16. When you add, how will you get 0? You're adding. See here, plus, plus. How can you get 0? Okay, you're squaring this, supposing this is 0. And you square this. See, because when you square something, children, you cannot get a negative answer. B minus C the whole square. B minus C can be negative. B minus C can be negative. B minus C can be anything. It can be 0. It can be positive. It can be negative. B minus C can be anything. It can be negative. The answer can be negative. The answer can be positive. The answer can be 0. Now, B minus C the whole, B minus C. Okay, we'll just assume it is 4 or minus 4. B minus C, we'll just assume minus 4. When you square it, you will get 16. And supposing the C minus A is 0, 0 square is 0. Now when you add 0 plus 16 plus 0, you will get 16, you will not get 0. Which means A minus B the whole square plus B minus C the whole square plus C minus A the whole square can be 0 only when A minus B is 0, B minus C is 0, and C minus A is 0. A minus B should be 0, and 0 square will be 0. B minus C should be 0, and 0 square is 0. C minus A, that answer should be 0, and 0 square is 0. Then only 0 plus 0 plus 0 will give you 0. Otherwise, you cannot get 0. See, we are getting an equation like this. A minus B the whole square plus B minus C the whole square plus C minus A the whole square is equal to 0. The answer is 0. How is that possible? As I told you, when you square it, the answer cannot be negative. It will be positive or it can be 0. So we took examples when, this answer is positive. When you square it, say you get 1. When you square it, say you get 4. You get here, when you square it, say you get 0. The sum is 5. The sum is 5. So when can you get 0 as a sum? Only when a minus b is 0. A minus b is 0. So 0 square is 0. B minus c is 0. So 0 square is 0. C minus a is 0 and 0 square is 0. And now 0 plus 0 plus 0 is 0. So from this equation, it is clear that a minus b is 0, b minus c is 0, and c minus a is also 0. If a minus b is 0, on transposing a is equal to b. If b minus c is 0, on transposing b is equal to c. And if c minus a is 0, on transposing c is equal to a. So we get the results. A is equal to b, b is equal to c, c is equal to a. That means a is equal to b is equal to c. So I'll quickly tell you what again. This is the given equation. We multiply both the sides by 2. And then we break 2a square as a square plus a square, 2b square as 2b square plus b square, 2c square as c square plus c square. Now we have 9 terms in all. Here we have 9 terms in all. Now we are going to group in threes. 3 plus 3 plus 3, 9 terms. How? Write out the middle terms first. Minus 2ab, minus 2bc, minus 2ca. Now accordingly choose the squares they must have. AB, so a square, b square. BC, so b square, c square. CA, so c square, a square. Like that. So like this, we group the 9 terms in threes. This is a minus b the whole square, b minus c the whole square, c minus a the whole square. At this point, we understand that a minus b should be 0. Then only 0 square is 0. Similarly, b minus c should be 0. C minus a should be 0. So if a minus b is 0, on transposing, a is equal to b. B minus c is 0, b is equal to c. C minus a is 0, c is equal to a. So from this, we get a is equal to b is equal to c. And we've proved that. Please write down, children. Write down and then you can ask me your questions.
Completed, ma'am.
All of you?
Completed, ma'am.
Completed, ma'am.
Completed, ma'am. Completed.
Yeah, next one. So prove that 2a squared plus 2b squared plus 2c squared minus 2ab minus 2bc minus 2ca is equal to a minus b the whole square plus b minus c the whole square plus c minus a the whole square. This is very easy. So I take you here. This is very easy, like similar to a little of what you learned from here. Now this is, we have to prove, see it, we'll have to prove that this one is equal to this one. So you can take only the LHS and work. You're not given an equation. You'll have to prove that this one, the LHS is equal to the RHS. So take up only the LHS. 2a squared plus 2b squared plus 2c squared minus 2ab minus 2bc minus 2ca. Take up only the left hand side. Okay, now break up. 2a squared is a squared plus a squared. B squared plus b squared, c squared plus c squared. All right, minus 2ab minus 2bc minus 2ca. Now there are 9 terms. There are 9 terms. So group it in threes like this. You already know this, children. So now this one is a minus b the whole square. This one is b minus c the whole square. This is c minus a the whole square, which is equal to the RHS. Hence proved. Isn't it easy, children?
Yes, ma'am. Yes.
Yeah. Yes, children. Please. Yeah, please write down. Is it over, children?
Yes, ma'am.
I'm doing, ma'am.
Okay. Class, use the emoji. Raise your hand. Rishmika, Shri, Sindhu, Sanjay, Tanishka, Raja, Madhumita, Arjun, and Srijana. Raja, you joined the session late?
Yeah, a little bit.
Okay. Yes, children.
Completed, ma'am.
Yeah. All of you?
Yes, ma'am.
Yes, ma'am.
All right. Yeah. So here it is factorize. You need to factorize this expression. It's only an expression. It's not an equation. See here, this is an expression. You'll have to factorize this expression. That is, find the factors, break down this expression, and write this expression as a product of its factors. So take up whatever is given here. Okay, this is the given expression to be factorized. A plus b the whole cube plus b plus c the whole cube plus c plus a the whole cube minus 3 into a plus b into b plus c into c plus c. Now, how does this look like for you children? Just a minute, children. Yeah, children. Yeah. So write down the given expression, which is to be factorized. Now, this looks like, if you look at this one as x cubed plus y cubed plus z cubed minus 3x, y, and z. Yes or no? Just see, I'll give you some time. Look at it. Look at this. X cubed.
Yes, ma'am. It looks like x cube plus y cube plus z cube minus 3xyz.
Yeah. X cubed plus y cubed plus z cubed minus 3, see here, x, y, see here, y, and z. So what is x cubed plus y cubed? What is x cubed plus y cubed plus z cubed minus 3xyz? What is this equal to? It's equal to x plus y plus z, x plus y plus z. So see here, x, a plus b, x plus y plus z into, oh, by mistake I put a minus here. There's no minus here, children. Into x square, into x square. So see here, what is x? This is x square. X square plus y square. See here, plus y square plus z square. Z is c plus a square, z square minus xy minus x into y minus yz minus yz minus xz minus xz. That's all, children. We're just factorizing using the identity. We're just factorizing using the identity. The identity is x cubed plus y cubed plus z cubed. Maybe you can write this. You can write this. I'll tell you where to write it. You can write it here. After writing this expression, you can write this one here. Okay, you can write the identity. X cubed plus y cubed plus z cubed minus 3xyz is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus xz. Now, where you can write x after this, you can write x is equal, what is x? A plus b. And what is y? What is y? B plus c. And what is z? C plus a. C plus a. You can write these two steps. After the first step, you can write these two steps and then continue. So see here, x plus y plus z. This is not there, children, by mistake. Now x square plus y square plus z square minus xy minus yz minus xz. Now after this, children, after this, see here, don't go ahead of me. This one is not there, children. This minus is not there. Okay. Now, when you simplify this bracket, see here, a plus b, open the bracket. What will you get? A plus b plus b plus c plus c plus a. A plus b plus b plus c plus c plus a. All right. So you will get a plus a 2a, b plus b 2b, c plus c 2c. On simplifying this one, a plus b plus a plus a is 2a, b plus b is 2b, and c plus c is 2c. And here in the next bracket, in the next one, I have made so many mistakes. There's a square bracket here, children. I've forgotten to put this. There's a square bracket here. From here to here, there's a square bracket. Yeah. All right. So when you simplify this one, you will get 2a plus 2b plus 2c. Now look at the second bracket. A plus b the whole square. That's nothing but a square plus 2ab plus b square plus b plus c the whole square. B square plus 2bc plus c square. C plus a the whole square. So c square plus 2ca plus a square. Then minus this into this. So you know how to multiply and get the four terms. A into B is AB, A into C is AC, B into B is B square, B into C is BC. That's what is here. And the minus sign outside. Similarly here, minus B into C is BC, B into A is BA, C into C is C square, and C into A is CA. Like that, multiply. The next step, here 2 is common. 2A, 2B, 2C. 2 is common, so take it out. 2 is common. See, when you factorize, whenever there's something common, you bring out the common factor. That's what we always do while factorizing. So 2 is common, bring out 2. So you'll get a plus b plus c like this. And in the second bracket here, open up the bracket. So you'll get a square plus 2ab plus b square. Open up the bracket, children. Open up the bracket. When you open up the bracket, what will happen here? Because it's too long, you know, I've just written the answer directly in the next step. You can understand, see here. Can you see an a square plus a square here? So 2a square. Then b square and b square, 2b square. Then the c square and c square, 2c square. Then see this 2ab, 2bc, 2ca. That's what I've written here. Because here everything is positive. So no problem. See here, everything is positive here, children. Till here, everything is positive. See this bracket from here to here. A square plus 2ab plus b square plus b square plus 2bc plus c square. Everything is positive. So a square, there's a square and there's a square here. So 2a square. There's b square, c square, c square. Then 2ab, 2bc, 2ca. So you can see all that here. 2a square, 2bc, 2b square, 2c square, 2ab, 2bc, 2ca. Now here I've, opened up the bracket. I've applied the minus sign to every term inside the bracket. I've applied the minus sign to every term inside the bracket. So here you have 4 terms. So here, 4 terms here, then 4 terms here, and the last 4 terms after applying the minus sign. Then you simplify. Certain things get cancelled, all that. And after simplification, you'll be left with only this one. A square plus b square plus c square minus ab minus bc minus ca. You'll be left with only this after simplifying. So like 2a square and there is one a minus a square here. So a square. Simplify, children. Simplify the like terms and you will get a square. The second bracket, you will get a square plus b square plus c square minus ab minus bc minus c after simplifying. So see, we have factorized. What is the last step? 2 into a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. Yes, children, please write down this one. It's also time. I'll do one thing. Let's not write in a hurry now. 1 minute. Take a screenshot. I'll just tell you. One minute. I'll tell you when to take a screenshot. Okay, then this I've corrected. And yeah. Now take a screenshot, children.
Taken, ma'am.
Yeah.
Taking ma'am.
Yeah. Since it's time, children, I don't want you all to copy this in a hurry. So go through the screenshot, understand more clearly, and then write it out on your notebook. I have 3 more. I thought I can finish it today, but yeah, I have 3 more. Please take a screenshot of this one. I'll explain this in the next class, but please complete this. Work it out in your notebook. I'll explain this in the next class. Take a screenshot, children.
Taken, ma'am.
Yeah, so 8 you have to write, 9, 10. Done?
Yes, ma'am.
Yes, ma'am.
And 11. That's all. Oh, 12. Oh, I don't know. Okay, this is 11. Just write it neatly in your notebook. You don't have, and okay, take a screenshot. Let me talk later. Done?
Yes, ma'am.
Yeah, this one, 12.
Yes, ma'am.
Okay. So I'll show you again from behind. 12. You don't have to understand anything. Just write it neatly in your notebook. I'll explain this in the next class. 11 also. Just write it neatly. Write it in one line like this. Use both the sides of the book. Write it like you cannot fit it in one page. No, so write it, on both the pages. Write it in one line. Don't write it, meaning whatever I've written, your answer should exactly look like this in your book. This entire thing should go in one line. So use both the sides of your notebook. So this also, this one also. Just write it neatly. Be careful with the signs. Write it neatly. I'll explain this in the next class. 9 also. This alone is explained. So please understand. Go through once again, understand, and then write on your notebook. 8 alone is explained. So go through and then write on your notebook. All right?
Yes, ma'am.
Yes, ma'am.
Yeah. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, children.
Yes, ma'am.
Thank you.
Thank you, ma'am.
Thank you.